Hello class. In your previous class, we have started the topic called periodicity or periodic properties of elements. And the first periodic properties that we discussed was atomic size. We came to know what is atomic size or atomic radius. After that, we have seen its trend. That means how it differs when you go from top to bottom down a group, as well as when you move across a period from left to right. So, in case of atomic size, as we know, when you move from top to bottom, the atomic size increases since the number of cells increases. Whereas when you move across the period from left to right, the atomic size decreases. This happens due to the reason that this happens due to the electrons are added in a same cell, which will lead to the force of attraction between the nucleus and the last electron, which will decrease its size. Okay, now today we are going to discuss about the second periodic properties, that is ionization potential, or we call ionization energy. Okay, so the definition tells us the energy required to remove an electron from a neutral gaseous atom and convert it into a positively charged gaseous ion is called ionization potential or ionization energy. So, whatever amount of energy that is required to remove the electron from the outermost, we can say, cell of a neutral gaseous atom so that it can be converted into a positively charged gaseous ion, we call it as ionization potential or ionization energy. The unit of ionization energy is expressed in electron volt. That is the unit. So, the energy that is required to remove an electron from the neutral gaseous atom to convert into a positively charged gaseous ion, we call it as ionization energy. Ionization energy depends on two factors: atomic size and nuclear charge. In case of atomic size, the greater the atomic size, the lesser the force of attraction. Since the electrons of the outermost cell lie further away from the nucleus, thus make their removal easier. That is, the ionization energy required is less. In case of nuclear charge, the greater the nuclear charge, greater is the attraction for the electrons of the outermost cell. Therefore, the electrons in the outermost cell are more firmly held, because of which greater energy is required to remove the electrons. So, this is how the ionization energy or ionization potential values will be changed as on the basis of the atomic size and nuclear charge. Now we'll see the trends in ionization energy. That means what will happen when you move from left to right. Across a period, the ionization energy tends to increase. Okay, so it increases as one moves from left to right across a period, because the atomic size decreases. The reason is that the ionization energy increases as we move from left to right, because atomic size decreases due to an increase in the nuclear charge, and thus more energy is required to remove the electron. So as we know that the size of the atom as we move from left to right decreases, and because of this small size, the electrons will have more pulling power towards the nucleus, so it will be difficult for us to remove the electron. That's why the ionization energy value increases. Say for example, in a second period, if you take the this elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, so ionization values increases. That means the neon will have a very high ionization energy. That means a huge amount of energy is required to remove the electron, whereas lithium can easily remove the less amount of energy. When you move down a group, what will happen? When you go down the group, there is an increase in atomic number. Okay, there is an increase in atomic number, that is nuclear charge, and atomic size down the group, and the atomic size down the group due to the addition of extra cells. This increase in the atomic size overcomes the effect of an increase in the nuclear charge. Therefore, ionization energy decreases with the increase in atomic size. That is, it decreases as one move down a group. So what will happen down a group? The ionization energy value decreases since the atomic size increases. So if the size of an atom is bigger, then the last electron will be far away from the nucleus. So if you supply a small amount of energy also, it will be easy to remove the electron. That will decrease the ionization energy value. Fine. So today we came to learn about the ionization energy, its definition, its unit, what are the different factors that it can depends upon. Then we discuss about how it changes as we move from left to right in a period, across a period, and also we have seen what will happen down the group. Okay, so the ionization energy value. Okay, now based on today's class, you have got the assignment number 3. Define ionization energy, write its unit. Question number 2, write the trends and regions as well for change of ionization energy in the following: down a group, across a period. Okay, so how the changes will take place and what will be the reason for that, you need to write it down. And question number 3, the ionization potential of potassium is dash that of sodium, whether it is less or high. You write it down. So complete this assignment and send it in my mail.